Okay, so this topic is sequences and series. You've done a bit of this at GCSE with the nth term and stuff like the Fibonacci sequence. We're just going to formalize that a bit more and extend it. So again, here's your reference grid to see where to get extra questions from using the Edexcel textbook, the AQA textbook, and the Solomon sheets. Okay, so we'll start off by talking about sequences. So as you know from GCSE, a sequence is just a pattern of numbers. So the notation we use at A level is we use the notation U and a subscript N. That just is the standard notation we use for sequence, for the nth term of a sequence. So if I have the sequence 2, 5, 8, 11, 14, for example, I would say U1 is the first term, so it's 2, U2 is the second term, so it's 5, U3 is the third term, so it's 8, etc. U, then a little number, just means what number in that sequence. Now, the letter U, we can use different letters, so we tend to use U, or we use X, or A. I'll try and use a mixture, so you get used to seeing different letters. But it just means sequence. If it's a letter, then a subscript, it just means a sequence. Okay, so sequences can be described in two different ways normally. So that sequence from before, 2, 5, 8, 11, 14, we can use a term-to-term rule. And you would have probably talked about this at primary school without formalizing it like how we did. That just means how do you get from one term to the next? So primary school, you probably would have said add 3. At A level, we're going to write that as UN plus 1 equals UN plus 3. So the UN plus 1 bit means the next term. So the N plus 1 means next. And the UN means the current term. Yeah, so it means the term I'm on now. So UN is the current term. Now, if we described a term like this by the term-to-term rule, we need to say what to start on. So I need to tell you what the first term is. So U1 is 2 in this case. So if I know the first term, and I know that to get to the next term, I add 3. I can work out every term in that sequence. We also have what's called a position to term rule. That's what you would have used at GCSE a lot. You would call that the nth term. And for that, it's going up in 3, so it's going to be 3n, but I have to take away 1. So we'd write that as un equals 3n take away 1. That's the most useful rule for writing a sequence using the nth term because you can do lots with it. However, term-to-term rules are also useful in different scenarios as well, especially when finding limits and stuff like that, which we'll explore in the next few pages. So 3 main types of sequences that you'll be familiar with already. So increasing, that just means where the next term is bigger than the previous term. Decreasing, the next term is smaller than the previous term. So those two are really obvious. And something called periodic, that just means that the sequence kind of repeats itself. So this notation here means that says UN plus K equals UN. That just means after K numbers, it repeats the sequence. So K is called the period of the sequence. So for example, if I had the term 1, sequence 1, 2, 3, 1, 2, 3, 1, 2, 3, I would say that's periodic, and the period is 3 because it repeats itself every 3. This can be thought of as cycles of 3. Equally, I could have 1, minus 1, 0, 2, 1, minus 1, 0, 2. That period would be 4 because it keeps repeating itself every 4 terms, etc. Yeah, we'll look at some other type of sequences later on. Okay, so first one, it says find the first 5 terms of each sequence and describe the behavior of the sequence. So I told you I'd use different letters. So for the first one, I've used X. So it told us that X1 is 2. Tell us what's that there. And it says Xn plus 1 is 5 times Xn, take away 1. So that just means the current term times by 5, take away 1. So x2 would be 5 times x1, take away 1. So I'll do 5 times 2, which is 10, take away 1 is 9. So I've got 2, 9. To get x3, I would do 5 times the current term, so 5 times x2, take away 1. So I'll do 5 times 9, which is 45, take away 1, which is 44. To get x4, it's 5 times x3, take away 1. So I'll do 5 times 44, take away 1, so 219. And to get x5, I would do 5 times x4, take away 1. So I'll do 5 times 219, take away 1, which would give me 1094. So there you go, there's the first 5 terms of that sequence, and that sequence is increasing. Yeah, it's constantly getting bigger. Okay, the second one, I've used the letter U this time, and it's the position to term rule. So this is basically the nth term, whereas the last one was a term to term rule. So this says UN is 32 divided by 2 to the power n. So U1 would be 32 over 2 to the power 1, which is 16. U2 would be 32 divided by 2 to the power 2, which is 8. U3 is 32 divided by 2 to the power 3, which is 4. U4 is 32 divided by 2 to the power 4, which is 2. And U5 is 32 divided by 2 to the power 5, which is 1. So all I was doing there is I was just changing the n in this formula into whatever term I wanted. So 1, 2, 3, 4, 5. And that sequence is decreasing. It's getting smaller each time. And the last one, I've used the letter A. So it doesn't matter what letters we use. Let's do this one in pink. So for C, this time it's a term to term rule again. So it's given me that the first term is 3. And it says the next term, so an plus 1, so that's the next term, is 1 over an. So the next term is 1 over the current term. So a2 would be 1 over a1. So a2 would be 1 over 3. So third. So it starts off 3, then the third. Then a3 would be 1 over a2. Yeah, if you're getting confused by where I'm getting these 3s and 2s from, it's just here, look, n plus 1 and n. If n plus 1 is 3, then n must be 2. If n plus 1 is 2, then n must be 1. Yeah, it just means the term before. Okay, and if we look back at it, a2 was a third, so 1 over a third is just 3. So a3 is just 3. And you can see what's going to happen. A4 would be 1 over a3, which is 1 over 3, which is the third. And a5 would be 1 over a4, so that's 1 over a third, so that's 3. So the sequence is going 3, a third, 3, a third, 3. This is periodic. And the period, well, it repeats itself every 2. So I can kind of think of these as cycles of 2. Okay, now we're going to talk about a limit of a sequence. So that means a sequence might head towards a number. So if we look at the last sequences, the first sequence was constantly getting bigger and bigger and bigger. It was getting exponentially bigger. Yeah, I was timesing the previous term by 5, then taking away 1. So that 1 is not going to have a limit. It's going to go off to infinity. And if it doesn't have a limit, then we say it's divergent. Yeah, divergent means it goes away from a limit. It does not tend towards a limit. It normally tends to like infinity or minus infinity. So divergent would have been that sequence which started off as 2, 9, 44, 219, etc. That was divergent. So I think that was sequence the first one. Sequence B, though, was convergent, because that means it's getting towards the limit. So if we think about those numbers, they went 16, 8, 4, 2, so they're just half in each time. So it's going to be 0.5 next, then 0.25. It's getting closer and closer and closer to 0. Yeah, so the limit of that sequence B, is 0. But again, not every sequence that does converge will go to 0, so you could get different limits. It doesn't have to be 0. Okay, so let's look at the next example. So find the first 4 terms of the sequence un plus 1 is 0.5 un plus 4, where the first term is 3. So I've got the first term is 3. To get the second term, I'm going to do 0.5 times the first term plus 4. So that's going to give me, so if I just write them here, so 3, then the next one will be 5.5. And I'm writing it as decimals, so it's a bit easier to see if there's a limit. To get the third term, it's going to be 0.5 times u2. So if n plus 1 is 3, n must be 2, plus that 4. So I'm going to type that in my calculator. You get 6.75. Actually, to type these in a calculator, if you press 3, then press equals, and then type in your calculator 0.5 times the answer button plus 4, and then keep pressing equals. It'll keep giving you a few sequences. So the next one would be 7.375. Okay, so this sequence converges towards a limit, L. Find the value of L. So you can see it's getting bigger, but it's slowly getting bigger. It's slowing down. So it looks like the limit could be 7.5 or 8 or 9 or even 10. So I'm just going to keep pressing equals on my calculator. And I've done lots of times, so now I can see my calculator 7.9999237. So I'm going to keep pressing equals, and I can see it's getting closer and closer and closer to number 8. So I'm going to guess that the limit's going to be 8. So to prove that, what we do is we say, if the limit converges to if the sequence converges to a limit L, that means un goes towards L. So you've seen a little arrow rotation when we looked at first principles. Now, if un converges towards L, then un plus 1 must also converge towards L. Now I'm going to look back at what the formula was, and I'm going to replace un plus 1 and un for L. So I get L equals 0.5 L plus 4. Now I'm going to take away 0.5 L from both sides. So on the right hand side, I just get left with 4. On the left hand side, I get L, take away 0.5 L. So I'm just left with 0.5 L. And then to get L by itself, I need times both sides by 2. So I get 8. So I do get that the limit is 8. Now that little trick we did here, where we turn un and un plus 1 into L, normally works. However, we have to be careful to check that the limit makes sense. So in this case, looking at the numbers, the limit did make sense. Let's look at an example where the limit won't make sense. So the sequence is given by un plus 1 equals 3 un plus 2, and the first term is 1. So what I'm going to do is I'm going to type 1 in my calculator and press equals, and I'm going to type in 3 times the answer plus 2, and I'm just going to press equals 2 times just to get the next few numbers. So it goes 1, then 5, press equals again, I get 17, equals again, I get 53. Let's just do it one more time. 161. Now, if I keep doing it on my calculator, I can see very quickly the numbers get really, really big. So it's going off to infinity. So this is called a divergent sequence. So it doesn't have a limit. But let's look at what happens if we did pretend it had a limit. So if I said that un goes to L and un plus 1 goes to L, I will get L equals 3L plus 2. If I take away 3L from both sides, I get minus 2L equals 2. So L would equal minus 1. So that's saying that those numbers will keep going towards minus 1, which doesn't make sense. So if you use this little technique, always check that your sequence that you're trying to find actually does have a limit. It's by working out the first few terms and using that answer button trick on your calculator. Okay, so we've looked at sequences. So let's now look at series. So a series is just the sum of a sequence. So it means we add up the terms in a sequence. And to do that, we call that a summation. So a summation is when we add together terms. So remember, the word sum means add. So summation is just the process of adding together lots of numbers. So if I use commas, look, 2, 5, 8, 11, that's called a sequence because it's a sequence of numbers. But if I add those numbers together, so 2, add 5, add 8, add 11, that's called a series. So series is when we add a sequence. A sequence is just a list of numbers. And again, we use UN, that notation, to denote the nth term. So 2 would be U1, U2 would be 5, etc. Now, the notation we use for a series is Sn. So, for example, if I was adding together the first 4 terms, that would be S4. So S4 would equal U1, add U2, add U3, add U4. So in this case, it will be 2, add 5, add 8, add 11. If I was doing U3, for example, that would be U1, add U2, add U3. So in this case, it would be 2, add 5, add 8. If I was doing S1, it would just be 2. If I was doing S2, it would be 2, add 5, etc. So the Sn is the sum of the first n terms. So add together the first n terms, that's what it means. We can also use the sigma notation to do summations. So this S notation is good if I'm starting from the first term, but if I don't want to start from the first term, I can use the sigma notation. Now, as a quick aside, the sigma notation is very similar to the integral notation. So if you think back to this is going to be very similar to summations and series. Yeah, so this is a Greek letter. It's an uppercase sigma, so like an S, and it means the sum of. So here's an example of one. And what this means, to work this out, all we do is we'd sub in values of R, because R is the letter given here. It could have been any letter in the world. They've said R, so I'm subbing in the values of R into this expression. I'm going to start with the bottom number, so R is 3. I'm going to go all the way up to the top number, so I'm going to sub in 3, 4, 5, 6, 7, and I'm going to add all those terms together. So in other words, to get the first term, I would sub in 3. To get the second term, I would sub in R is 4, sub in R is 5, sub in R is 6, sub in R is 7, work those numbers out, then add them together and I'll get 65. Okay, now let's have a go at seeing if we can do the same thing. So write down all the terms in the series. So the first one, again, we're using the letter R, and we're starting from 1 and we're going up to 5. So I'm going to sub in 1 for R, sub in 2 for R, sub in 3 for R, sub in 4 for R, and sub in 5 for R. I'm going to work those out and then add them together. Remember, series means add together. Yeah, and then if I wanted to work that out, I would add them all together. Now I want to see if you can find on your calculator. Even the non-fancy ones have these. If on the fancy one, if you click on Calc, so where you get the integration button and the solve n button, and press along, you'll see the sigma notation. Then if I just type it in, so if I type in 3, I'm just going to use the x button. So x squared minus 5. And then I'm going to write x equals 1 on the bottom, and then put 5 on the top, and it'll do the sum for me, and I get 140. So I can check that by adding those numbers together, I should get 140. Yeah. Just gonna and I should get 140. See, this is why calculus got to check, because that last time should have been 70, not 72. Okay, next one. So again, we're using the letter R. We intend to use the letter R, but it doesn't have to be R. We're starting with 2 and going up to 4. I'm going to sub in 2. I'm going to sub in 3. I'm going to sub in 4. Then I'm going to add them together, so I get the third, add 1 over 4, add 1 over 5. And if I add those together, again, you can use a calculator to work it out for you. 1 over, I'm going to use x plus 1. And I'm going to go from x is 2 this time, up to 4 at the top. And I get 47 over 60. And the last one, we're using R again, and this time we're starting with 3 and going up to 5. So I'm doing minus 2 cubed plus minus 2 to the power 4 plus minus 2 to the power 5. So I get minus 8 plus 16 plus minus 32. And again, I can type that in my calculator. And get minus 24. Equally, I could be given a sequence or a series and be asked to write them using the sigma notation. And there's an infinite number of ways of writing them. So for the first one, if I think minus 1, 2, 7, 14, 23, that's going up in threes. No, it's not going up in 3, sorry. It's going up in 3, then 5, then 7, then 9. So the second difference is 9. So remember back to GCSE, the second difference is 3, then 5, then 7, then 9. Second difference is 2. So that means it's going to be a squared nth term. So if I think of it as n squared, well, to get from n squared, the first term would be 1. I need to take away 2. And let's check if that works for the next one. So 2 squared is 4, take away 2 is 2. 3 squared is 9, take away 2 is 7. 4 squared, 16, take away 2 is 14, and 5 squared, take away 2 is 23. That works. It looks like I'm using the letter n this time. And I'm going to start with the number 1 and go up to the number 5, because that's what gives me the 23. Okay. The next one, I've got 1 over 5, add 1 over 7, add 1 over 9, all the way up to 1 over 21. So if I ignore the 1 overs and just look at the numbers in the bottom, 5, 7, 9, 11, 13, etc. It's going up in 2s. So I can think of this, and I'm going to use, let's use m just to change it up, 2m. Now, the first term in that sequence would be a 2, so I'd have to add 3 to get 5. And I would want that to go from m is, well, 1. If I sub in 1, I'll get 5. What would I sub in to get the number 21? So if I make 2m add 3 equal to 21, I can solve that to get 2m is 18, which gives me m is 9. So I'm going from m is 1 to 9. Equally, though, I could have used the mth term 2p, add 1. Now that will work if I start with p is 2. Because if I sub in 2 into there, I would get 4, add 1, which is 5. If I sub in 3, I get 6, add 1, which is 7. If I sub in 4, I get 8, add 1, which is 9. So that's the first 3 terms of my sequence. And what would p be to get the last term? So 2p add 1 is 21. I can take away 1 from both sides. I can divide both sides by 2, so I get 10. Yep, so you can see that if I change my mth term, my limit's changed. Yeah, so there's more than one way of writing a series. Okay, let's talk a bit about the notation. So if we have a sequence, let's call it un, then we can write a series for that in terms of UNs. So for example, I just pick some random numbers. I want to start from the second term. So when r is 2 to 5, again, I've used the letter r. I could use any letter I want. That means add together the terms of that sequence starting at 2 going up to 5. So u2, u3, u4, u5, add them together. So add together those terms there. In particular, Sn, that notation I mentioned before, is the series when I start at 1. So that means start with u1, u2, u3, all the way up to un and add them together. Now, just like integration, hopefully you can remember from integration that if I'm adding, I can separate. If I'm integrating and timesing, so if I'm timesing by 2, for example, I can put the 2 on the outside. Yeah, these rules work with series as well, with the summation symbol. So let's just look at this. I have the series of a sequence AR from 2 to 10 is 20, and the series from 2 to 10 of a different sequence BR is 30. So we've got 2 different sequences, AR and BR, and the sum from the terms 2 to 10 are 20 for A and 30 for B. And we want to find the value of AR plus BR. Well, you can think of that as, if I sub in the first number, so it's A2 add B2, add, then sum in 3, so it's A3, add B3, add all the way up to A10 plus B10. Now with adding, I can add all the A's together first, can't I? So I could do A2, add A3, all the way up to A10. I can do all the B's together, so B2, add B3, all the way up to B10. And then add those together, because I know that the A's add up to 20, the B's add up to 30, so I can just add them together and get 50. So what that example is trying to show you is if there's an add in the middle, I can do them separately, I can separate them. The next one says if I times each term by 3, so I would get 3A2, 3A3, 3A4, etc., all the way up to 3A10. And I know I could factorize out the number 3. And A2, A3, all the way up to A10, they add together to give me 20. That's what the question told me. So it's 3 times 20, which is 60. So what that example is trying to show us is if I'm timesing my sequence by number, I can factorize out that number. Okay, and the last one is the sequence A2 take away 3 this time. So the first term would be A2 take away 3. The next term would be A3 take away 3. The next term would be A4 take away 3, all the way up to A10 take away 3. Okay, this one, I want to see if you can guess what the answer might be. So you might think I just take away 3 from 20. However, I hope we can spot that's not the case. So I could do all the A's together, so A2 all the way up to A10. But in terms of the minus 3's, I can put them together as well. I'm going to have more than one minus 3. So the A's add up to 20, and the minus 3's, you have to think, what do the minus 3's add up to? So basically, how many are there? Well, I'm doing the terms from 2 to 10. So have a think how many minus 3's will appear if I'm doing all those terms. And I'm going to guess you're going to say the number 8. However, there's actually 9. Now, think about it, I'm counting out loud. There's the second term, third, fourth, 5, 6, 7, 8, 9, 10. Now, if you count those, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 lots of minus 3's, so that gives me minus 27. So when I do 20 add minus 27, I get minus 7. So when you're counting how many terms you have in the series, it's so easy just to think you take away those numbers, but you have to remember to add 1 to it, because you have to remember to count the number you're starting on. So if I'm going from 2 to 10, difference of 8, I need to count the number I started on, so there's 9 terms in that series. Okay, now let's see if we can explore a bit more about these sequences and series. So a sequence has got a formula for the sum of the first n terms given by Sn is n cubed. So to get the sum of the first n terms, I just cube what n is. So that means, for example, if I pick a random number, so let's use 3. So S3 would be 3 cubed. So that means U1, add U2, add U3. So the first 3 terms of a sequence, but add together to give me 27. That's what that formula means there. Okay, and the first thing we're trying to find out is what is the value of the first term, so U1. Okay, well, the first term, U1, is actually the same thing as S1, because the sum of the first term is just the first term. There's only one term there, isn't there? So to get the value of U1, that's the same as S1, and we have a formula for S1. It's 1 cubed, so it's just 1. So my first term is just 1. Okay, part B, find the sum of the first 15 terms. Starts asking me to find out S15. So that's 15 cubed using the formula. And 15 cubed is 3375. So that means the first 15 terms, so U1, add U2, all the way up to U15, adds up to 3375. Okay, part C is saying find the value of the sum from 10 to 15 of my sequence. So it's asking for U10, add U11, add U12, add U13, add U14, add U15. It's asking me for what's the value of that. Now, unfortunately, my formula, the only formula I've got, Sn, has to start with number 1. So if I add all these terms in, starting from 1, so U1, add U2, add U3, I think my handwriting's too big, add U4, add U5, it is. Can I move that? Oh, I can, amazing. Add U6, add U7, add U8, can I move that again? I can. Oh, technology. Add U9. So if I start with the first term, that gives me everything I want up to 15. So that, what I've got written down, gives me S15. All the numbers, all the terms from 1 to 15. However, I only want the red ones. So to get the red ones, I need to take away those blue ones. So I need to take away the terms from 1 to 9. So I need to take away S9. And I know how to work out S15 and S9. S15 we just worked out as 3375. S9 would be 9 cubed using the formula that the question told me. So 9 cubed is 729. So 3375 take away 729 gives me 2646. So my summation is 2646. Okay, and this trick that I did here of if I've got the formula for Sn, so that means I need to start at 1. If I add all the numbers in, starting at 1, and then just take away the numbers I added in. So if I wanted, for example, the sum from R is 20 to 50 of UR, I would do S50, so all the numbers from 1 to 50. Then I need to take away the numbers I added in, which are the numbers from 1 to 19. So I need to take away S19. Yeah, have a think about that. Have a play around with a few of those. See if you can spot how that works. Okay, D's asking for the sum of the first 14 terms. So that's asking for what is S14. So that's just 14 cubed. And 14 cubed is 2744. E, what's the value of U15? So it's asking for just one specific term. It's asking for U15. Well, my formula only lets me work out the sum from U1 to that number. So if I do U1, U2, all the way up to U15, so I need U14 as well. Then to get just U15, that's S15, take away my blue ones, so take away S14. Now S15 we've worked out, that was 3375. S14 we worked out is 2744. So I can take them away. And get 631. So the 14 term is 631. And finally, find an expression for UN. Well, using that same technique as before, to get the 15th term, I did the sum to 15, take away the sum to 14. And that, when I took them away, that just left me with the 15th term. Well, if I want un, I need to add all the terms u1, u2, all the way up to un, so I need the number before, so un minus 1. So if I want what un is, I need the sum all the way up to n, take away the sum all the way up to n minus 1. Now, you remember what formula is, so look back to the top of the page. Sn is n cubed, so Sn minus 1 will be n minus 1 cubed. Okay, so then if I keep simplifying that, I get n cubed. Now if I expand that using binomial, remember the triangle 3 is 1, 3, 3, 1. I get n cubed, take away 3n squared, minus 1 squared will give me plus 1, so I get plus 3n, and then minus 1. And then when I simplify that, n cubed take away n cubed disappears, cancel out, so I'm left with 3n squared minus 3n plus 1. So that's my nth term for that sequence. And if I sub in 15, just to check, I should get 631. And I do. So that nth term does work. So again, that's a nice little trick, this formula here. If I want the nth term of a sequence and I have the Sn formula, I just do Sn take away Sn minus 1. So just like we did for U15, I did S15 take away S14. Okay, let's look at a bit more at periodic sequences because they're really interesting. So I've got a periodic sequence of period 5, so that means it repeats itself every 5 numbers. And the sequence starts with 2, 5, 3, 9, 1. So there's my first 5. Then those 5 keep getting repeated. So 2, 5, 3, 9. There should be a 1 there. That's a typo. That 2 should be a 1. Sorry, so it keeps repeating itself every 5 terms. So if I want to find the 37th term, well, if I think of the terms like this, U1, U2, U3, U4, U5. They're the numbers 2, 5, 3, 9, 1. So U6 would also be 2, U7 would also be 5, U8 would also be 3, U9 would also be 4, and U10 would also be 1. And if I want the 37th term, I need to think, where will 37 lie on this grid? Well, I'm not going to write all the numbers out to 37, but I am going to spot that this last column, look, is the multiples of 5. So I know U35 is going to be there. So that means U36 will be here, and U37 will be there. So U37 will be in the second column, so that's just going to be 5. So U37 was 5. If I want the 102nd term, so again, I'm not going to write all the terms out, but I want to think, which number do I know will go where? Well, again, the last column is multiples of 5, so I know that U100 is going to be in that last column, so that means U101 will go there, U102 will go there. So again, the 102 term will be 5 again, will be the second term. And if I want the 1400 term, so 1400, well, that's a multiple of 5, so that'll lie in the last column. So that's going to equal 1. Yeah, so this is all to do with finding out what's the remainder when I think of it in terms of 5. So if the remainder was 1, it will be in the first column, so 2. If the remainder was 2, it will be in the second column, 3, third column, 4, fourth column, and if there's no remainder, so if it is a multiple of 5, it will be in that last column there. And D is asking for what's the sum of the 61st terms. Okay, well, let's think of this. Each row is going to have the same sum, isn't it? So let's think, what's the sum of the first rows? 2, add 5, add 3, add 9, add 1. So that sum there is 20. So each row will give me a sum of 20. Well, if I'm going to 61, how many full rows can I get from that? Well, I know I'm going to have U60 in this column and U61 here. So I'm going to have, it's going to go 5, 10, 15, 20. So how many 5s go into 60? I'm going to have 12 full rows. So that means I'm going to have 12 lots of 20. And then I'm going to have this one extra term here, which is in the first column. So I'm going to have an extra 2. So I'm going to have 12 lots of 20. And then add that extra 2. So the sum of the 60 first terms is 2, 4, 2. Yeah, periodic sequences are really nice if you think of them as columns and rows. So here's 2 for you to have a try yourself. So maybe pause it and try them, and then check your answers. So first one, find the period of that sequence. Well, if I sub in U1, I get, if I sub in 1, I get sine 90, which is 1. If I sub in 2, sine 180, which is 0. U3, sine 270 is minus 1. U4 gives me sine 360, which is 0. And if I sub in U5, I get sine 450, which is 1. So I've got back to 1 there. And we know that sine repeats itself every 360. So this sequence is going to go 1, 0, minus 1, 0, 1, 0, minus 1, 0. So the period is 4. If I want to find the value of U13, we'll think, where would U13 land? Well, the last columns is going to be the multiples of 4. So we're going to have U12 in there. So U13 will go in the first column. So that will be a 1. Or I could just sub in 13 into the formula and check what you get. And it says find the value from 1 to 101. So that's asking me for S101. Well, I know that the row adds up to, if I add those numbers together, I get 0. So one row adds up to 0. And that row is the first 4 terms. Well, the number 100 is a multiple of 4, so that's going to go in this last term. So I'm going to get 101 left over. So think, how many rows will there be to get to 100? So how many 4s go into 100? There'll be 25 rows. So I'm going to have 25 lots of 0, plus this extra term lying around, which is in the first column, so that's a 1. So the sum of the first 101 terms will be 1. And the second one, well, let's do the same thing. So let's work out what the first term is. The first term I've told is 0. So if I sub 0 in, 0 squared is 0, minus 1 is minus 1. Now if I sub in minus 1 squared is 1, take away 1 is 0, so U3 is 0 again, and then U4 will be minus 1 again, and it's a period of 2. It's just going to go back and forward between 0 and minus 1. So U13, well, U12 will be in the second column, because it's a multiple of 2. So U13 will be in the first column, so that's going to be 0. You can also think of this one as even and odd, actually. If it's even, it's minus 1. If it's odd, it's 0. And it wants S101 again. So I know that one row adds up to minus 1. So if I'm going from U1 to U101, well, U100 is going to be in this column, and U101 is going to be in that one. So how many rows? 2 and 100. So how many 2's going to 100? It's going to be 50, plus that one term left over. So I'm going to have 50 lots of minus 1s plus this extra term here, which is in the first column, so it's a 0. So that gives me minus 50. Okay, you might want to do some more practice now of periodic sequences because they're quite interesting. And try and draw these paddings with the columns and the rows. They really help with these questions. Okay, the next type of sequences we'll look at, and these will be some routine GCSE already, called arithmetic sequences. So an arithmetic sequence is a sequence where a fixed amount is added to get the next term. So we call that amount the common difference, and I'm going to denote that with the letter D. And the first term, since that's going to be the most important term, instead of writing U1 all the time, I'm just going to write the first term as air. So I'm going to write U1, I'm going to call that air, and I'm going to say the rule is to get from one term to the next, I add this common difference. So to get the next term, I add D to the previous term. So UN plus 1 is UN plus D. D could be a negative number, for example, it could be minus 2, it could be a positive, it could be a fraction, it could be decimal, it could be 0. So the first term is air, the second term is air plus D, the third term is air plus 2D. Hopefully you can see the padding. So U1, U2, U3, U4, U5. So U3, the third term, is air plus 2D. U10, well, I'm going to start with air, and I'm going to add, well, to get to the 10th term, there'll be 9 differences, so 9D. And the nth term, to get UN, I'm going to start with air, and I'm going to add on n minus 1Ds. And that formula is one you have to memorize. For an arithmetic sequence, the nth term is air plus n minus 1D. Now, if you have a quick check, so if I think of, let's do add in the number 2, so the sequence here. So air would be 5, D would be 2. So to get the nth term using this formula, I would get 5 add n minus 1 times 2. And if I expand and simplify, I would get UN is 2n plus 3, which is what you probably would have told me at GCSE. Yeah, so this method works as well. Just this formula in blue is a nicer way of writing it instead of the way you did at GCSE, where it's kind of work out the difference, then kind of guess what it is you need to take away or add. Okay, here's an example. So the 5th term of an arithmetic progression is just another word for sequence. So the 5th term of an arithmetic progression is 7, and the 8th term is 16. So just from that sentence, I can write down 2 key facts. I can write the 5th term, so U5 is 7, and U8 is 16. And part A is asking me to find the first term air and the common difference D. Well, I've got a formula for U5 and for U8. If I use this formula up here, it's U add, so air add n minus 1, so 5 minus 1D, and that's going to equal 7. And similarly for U8, air add 8 minus 1D equals 16. Now if I simplify that, I get air add 4D is 7, and air add 7D is 16. So I've got 2 simultaneous equations, so I can solve them on my calculator. You can just take them away, so there is cancel out very quickly. I won't be able to do it. I think this one's quick enough just to take them away. So if I do 2, take away 1, I get, well, 7D take away 4D is 3D, and 16 take away 7 is 9, so D is 3. And if I sub D back in the first one, I get air plus 12, 7, so air is minus 5. And I'm just going to check that on the second one. So minus 5 add 3 times 7, so minus 5 add 21 does give me 16. So I'm confident that I've got the right answers. And then B says, hence find the 100th term. So part B is asking me to find U100. So using the formula, that's A plus 100 minus 1D. Well, I know A is minus 5, 100 minus 1 is 99, and D is 3. So it's minus 5, add 99 times 3, which gives me the 100th term is 292. Okay, here's another one. The first 3 terms of an arithmetic sequence are 12, x squared, and 5x. So that's the key word that's arithmetic. So you could write u1 is 12, u2 is x squared, and u3 is 5x. And you could use the formulas for an arithmetic sequence to get 3 equations in terms of A, D, and X. However, I don't really want to solve a simultaneous equation with 3 equations. So let's think of a nice way of doing this. So if we want to find the possible values of X, well, if it's arithmetic, that means the common difference is constant. So to get from U1 to U2, I would add D. And to get from U2 to U3, I would also add D. So this difference is common, it's equal. So how would I get the difference from U1 to U2? I would do U2 take away U1. And how do I get the difference between U3 and U2? I would do U3 take away U2. And that must be equal, because the common difference is common, it's equal each time. So if I sub in what U1, U2, and U3 are, so U2 is x squared, take away U1 is 12, U3 is 5x, take away U2 is x squared. Now if I rearrange that to make it like a quadratic, so I'm going to add x squared to both sides and take away 5x. And now I've just got a quadratic, which again I can just use my calculator to solve. So 2 minus 5 minus 12. So I get my values for x is 4, or x is minus 3 over 2. So 2 possible answers for x. And again, what this would look like if I subbed in 4, I would get 12. So if x was 4, I would get 12. 4 squared is 16. 5 times 4 is 20. So that, yep, that works. That's arithmetic. It's gone up in 4s. And if x was minus 3 halves, then I'll get 12. I will get minus 1.5 squared is 2.25, and 5 times minus 1.5 is minus 7.5. And again, that's arithmetic. It's a bit tricky to spot, but the common difference this time is minus 9.75. Yeah, so 12 take away 9.75, it's 2.25. If I take away 9.75 again, I get minus 7.5. So it works, they're both arithmetic. If I want to talk about an arithmetic series, if I'm adding together the first n terms, so if I'm adding together for an arithmetic series where the first term is A, the common difference is D, and the nth term, so the last term of my sequence I'm adding together is L, then the sum of the first n terms is given by the formula n over 2 times A plus L. Or equally, I can write it in terms of just n, so no L's, n over 2 times 2A plus n minus 1 times D. Now that formula you're actually given. This formula you're given in a formula booklet, so you don't have to memorize this one. Now to prove it, this goes back to a mathematician called Gauss, who came up with this idea in a lesson when he had a supply teacher once. I'll tell you this story in class, because it's an interesting story. I might even time you to see how long it takes you to add some numbers together. And the proof goes, well, my sequence I want is, the first term is A, the second term is A at D, the next term will be A at 2D, and I'm going all the way up to L. So the term before that will be L minus a difference, L minus D. The term before that will be L minus 2D, and I'll have lots of terms in the middle. Now the trick is, what Gauss thought of, is what happens if I write that sequence, that series in reverse. So I put L at the front, then L minus D, then L minus 2D, have lots of numbers in the middle, then A will be at the end, then A plus D will be second from the end, and A plus 2D will be the next one. And if I add those two equations together, I get two lots of SNs, so two lots of my series, my sum. Well, the first term gives me an A plus L. The second term would be A plus D plus L minus D. So the D's would actually cancel out. So I just get another A plus L. Same for the two D's, cancel out, again A plus L. And that's going to happen with all the terms in the middle. The two D's cancel out, so I get A plus L. The D's cancel out, so I get A plus L. And my last term gives me A plus L. And there was n terms, so I'm going to have n lots of A plus L. So I put n lots of A plus L. And so to get Sn by itself, I just need to divide by the 2. So it's n over 2 A plus L. Yeah, and if I want a second formula, I just have to remember that L is the nth term to the last term. So the formula for that is A plus n minus 1D. So if I sub that in for L, I get that second equation, which is n over 2. I would have two A's now, plus n minus 1D. Yeah, on the old spec, you could get asked to prove that formula, so it's good to know how to prove it, or at least to see where it comes from. Okay, so now let's look at some problems with that formula. So an arithmetic sequence has first term 5 and common difference 10, and the sum of the first n terms is 720, and we want to find the value of n. Okay, so let's read through that again and write down some key information. So I know it's arithmetic, so that means I can use the formulas. Un is A plus n minus 1D, and Sn is n over 2 A 2A plus n minus 1D. You get the second one, not the first one. The first term is 5, so I know that A equals 5. The common difference is 10, so I know that D equals 10. And the sum of the first n terms is 720, so I know that Sn is 720. Okay, so that's the fact it's going to be useful. So I've got a formula for Sn. So I've got n over 2 times 2A plus n minus 1D equals 720. Now I know what A and D are. So if I sub those in, I get n over 2. 2 times A, so 2 times 5 is 10, plus n minus 1 times D, which is 10. So I'm just going to put 10 to the front of that bracket, equals 720. Now to solve this, I could times both sides by 2, but I'm just going to expand that bracket by the half instead. So I'm going to get 5 plus 5n minus 1 equals 720, just to make the numbers smaller rather than bigger. But if you want to times both sides by 2 instead, you can. Now I'm going to simplify the bracket inside. So I'm going to get 5 add 5n minus 5 equals 720. So that bracket just simplifies to the 5 cancel out, so I get 5n equals 720. So I get 5n squared is 720. So if I divide both sides by 5, I get n is 720 divided by 5 is 144. So to get n, I can square root both sides. So I get n is, I would get 12, or n is minus 12. But as I'm talking about a number of terms, I can't have a negative number of terms. So n would be 12. Okay, next one. The sum of the first 10 terms in arithmetic sequence is 185. The sum of the first 20 of the same series is 720. And we want the first term and a common difference. So it's asking for A and D. The first bit tells me that S10 is 185 and S20 is 770. So if I use the formulas, so n over 2, but I know that n is 10. So 10 over 2 times 2a plus n minus 1, so 10 minus 1 d equals 185. Similarly for the second one, n over 2, so 20 over 2, lots of 2a plus 20 minus 1 times d, 770. Now let's simplify that. So I get 5 lots of 2a plus 9d is 185, and 10 lots of 2a plus 19d is 770. Well, I could expand, or I could divide both sides by 5 in the first one. So 2a plus 9d is 185 divided by 5 gives me 37. Divide both sides by 10 on the other one. So 2a plus 19d is 77. Again, I could use my calculator to solve simultaneous equations. Or again, this could be nice and quick to do by hand. So I'll call this one 1, this one 2. If I do 2, take away 1, 2 ways will cancel out. So just get 19d, take away 9d, so 10d is 77, take away 37 is 40, so d is 4. And if I sub that back in, sub back into the first one, I get 2a plus 36 is 37, so 2a is 30, 2a is 1, sorry, so a is a half. And again, I can check that in my second equation. So 2 times half is 1, 4 times 19 is 76, and 1 add 76 is 77. So my common difference is 4, and my first term is a half. It's just simultaneous equations. So it's just using this formula here, the one you're given, the SN formula, by subbing in 10 and subbing in 20. So remember that the trickiest bit about maths is turning the words into formulas. So picking out these bits of information. So getting rid of all the words and just writing that down. That was the trickiest part to this example. Okay, let's do one more. So an arithmetic series, arithmetics, that's key. That means I can use the formulas for UN and SN. So I'm just going to write them at the top. So they're not in my short-term memory. And SN is n over 2 2a plus n minus 1d. Has the first term of 4 and a common difference 5, and the nth term is un. Find the sum from 55 to 100 of un. Okay. Well, there's multiple ways of doing this. One way I could do it, so method 1, is I could work out what the nth term is. So un is a plus n minus 1d, so it's 4 plus n minus 1 times 5. I can simplify that to give me un is 5n minus 1. So I'm asked to find this. So I could just type down my calculator and that'll give me an answer. Or I could spot that 55 if I sub in 51, so 5 times 51, take away 1. So my sequence is starting with 254. Then if I put the next one in, it should go up in 5, so I get 259, all the way up to, if I sub in 100, so 5 times 100, take away 1, gives me 499. So I've got an arithmetic sequence here, where the first term is 254, the common difference is still 5, and the number of terms, well, I'm going from 51 to 100, so there's a difference of 49 between them, but I need to count the first term, so I need to add one more on, so there's 50 terms. So I can use the SN formula, so I can do S50 is N over 2, so 50 over 2, times 2 times A, so 2 times 254, plus N minus 1, so 50 minus 1 times D. And I can put all that in my calculator and get 18825. So that's method 1. The method I prefer, let's do this one, different colour. The method I prefer is using that same trick from before. So if I want the sum from 51 to 100 of UN, that's the same as going all the way from 1 to 100, so S 100, take away, well, if I need to start at 1, I need all the numbers from 1 to 50, so I need to take away S 50. So using the information in the question, so A is 4, D is 5. So the reason below where A was slightly different number is because I was working with a different series here. I was starting with 51. Whereas here, I'm starting with N is 1. So I don't need to worry about that. So A is 1, A is 4, D is 5. So S 100 would be 100 over 2. So N over 2 times 2A, so 2 times 4, plus N minus 1, so 100 minus 1 times 5. Take away S50, so 50 over 2. Take away 2A, so 2 times 4, plus N minus 1, so 50 minus 1 times D, so times 5. And type that in my calculator. So the first term gives me 25150. And the second term gives me 63250. 25, sorry. And if I take them away, I get the same answer as before, which is what I was hoping for. So 2 different ways of doing it. So one is by making a new arithmetic sequence, so write out all the numbers I want and use the SN formula on that, where the A will be different because I'm not starting with the first term, or change my series. So instead of starting at 51, I start at 1, so I get S to 100, and then S50, so 1 to 50, take them away, and get the same answer. Okay, so you might want to do some practice on arithmetic sequences now. Okay, the next type of sequences we'll look at are geometric, and geometric is kind of like the next step up. So a geometric sequence is one in which each term is multiplied by a fixed amount to get the next term. So this amount we times by is called the common ratio, and we use the letter R. Again, the first term we use the letter A for. So the term-to-term rule, well, U1 would be A, and to get the next term, so to get UN plus 1, I times the current term by R, so it's UN times R. So the first term would just be A, the second term would be AR, the third term would be AR squared, the fourth term would be AR cubed, etc. Yeah, now it says multiplied, but equally could be divided by a number. So remember, dividing by 2 is the same as times by half. Dividing by 5 is the same as times by 5th. Dividing by half is the same as times by 2. Now, if you look at the padding, the 5th term would be, well, I need times by 4 to get to the 5th term. U6, I need to times the 1st term by R 5 times. And so to get the nth term, I need times by R n minus 1 times. So this formula here is one you don't get given, so you're going to have to remember it. So if I have a sequence, it's 6, and I'm times them by 2 each time. So 12, 24, 48. So here A would be 6, R would be 2. So my nth term would be 6 times 2 to the power n minus 1. Now what I can't do is I'm not allowed to do this. I'm not allowed to do 6 times 2 and put 12 n minus 1. I'm not allowed to do that. Different bases, so I can't times them. But what you can do, and it's up to you to decide if this is useful or not, I could split the 2 up. So using the indice rules, I can write that as 2 to the n divided by, because it's take away 2 to the 1, which simplifies to 6 divided by 2 is 3. So 3 times 2 to the power n. Yeah, you might prefer that instead of the n minus 1. It's up to you. Just like with the arithmetic one, you can expand the bracket. With this one, you can split up the power. So if there's a takeaway in the power, that means when I split it up, it turns into divide. So 2 to the power n divided by 2 to the power 1. Let's look at an example. So the 7th term of a geometric sequence is 13. The 9th term is 52. Find the possible values. So there's more than one, the common ratio. So that's asking me to find R. Well, again, let's do the bit where we pick out the key bits and turn it into facts, mathematical facts. So the 7th term is 13. So U7 is 13. And the 9th term is 52. So U9 is 52. It's geometric, so I can use the UN formula. So UN is R n minus 1. So if I sub 7 into there, I get R 7 minus 1 is 13. And if I sub 9 in, I get R 9 minus 1 is 52. So R to the power 6 is 13. And R to the power 8 is 52. So 2 simultaneous equations. Now we calculator won't solve them this time because they're not linear. So I number them 1 and 2. Now this time, I could rearrange to get A equals or R equals and sub it in. But the quickest way, if you look, this might look familiar when we did a bit of trig. If I divide them, the A's will cancel out. So if I do 2 divided by 1, so I'm choosing 2 first because it's got the bigger power. So if I do AR8 divided by AR6, that'll equal 52 divided by 13. Now the A's will cancel out, and R8 divided by R6 just gives me R squared, so take away the powers, and 54 divided by 13 is 4, so R squared is 4, so R equals 2, or R is minus 2. And if we wanted the first term, we would sub those back in to either 1 or 2 to get what A is. So the question just wanted common ratio of them. Okay, here's another one. So 3 terms of a geometric sequence, or 3 consecutive terms, so it's 3 terms after the other. Common ratio is not 0, or x minus 2, x plus 2, 5x minus 2. So I could write them as u1 is x minus 2, u2 is x plus 2, and u3 is 5x minus 2. Now I could, if I wanted, could use the formula for un, so r to the power n minus 1, and get 3 simultaneous equations, but I don't really want to solve a 3-way simultaneous equation. So instead, let's think about what is a geometric sequence. So u1, u2, u3. So to get from u1 to u2, I times by r, and to get from u2 to u3, I times by the same number r. So that ratio is the same. So what do I times the first one by to get second one? So what do I times u1 by to get u2? I times by u2 over u1. That gives me the ratio. And to get from u2 to u3, I times by u2 or u3 over u2. So those ratios must be equal. So if I sub them in, so u2, so I get x plus 2 over x minus 2 equals 5x minus 2 over x plus 2. Now if I times both sides by the x minus 1, the x minus 2 and x plus 2 to cancel them out, I get x plus 2 squared equals 5x minus 2 times x minus 2. So you might remember this is just cross multiplying. Times on both sides to cancel out the denominators. If I expand both sides, so I'll get 5x squared, I'll get minus 10x, minus 2x, so minus 12x, and take everything to one side to make it equal 0, so I get 4x squared minus 16x, the minus 4's cancel out, and then solve that. Well, this one's, I don't need my calculator to solve this, because I can factorize out 4x. So I get either x is 0 or x is 4. So I've got the first part, where the first part is asking for the possible values of x. For each value of x, find the common ratio of the sequence. Well, if it was 0, let's look what would happen. So if x was 0, I'll get minus 2, 2, minus 2. Just sub in 0 into x minus 2, x plus 2, 5x minus 2. So for that one, common ratio would be minus 1. And if x was 4, I will get 4 take away 2 is 2, 4 add 2 is 6, 5 times 4 take away 2 is 18. So that one, the common ratio will be 3. Okay, let's look at another one. A geometric sequence has first term 10 and common ratio half, so that's telling me that it is 10 or is a third. I think I said half, didn't I? I meant a third. What is the first term that is less than 10 to the minus 6? So I'm trying to find un less than 10 to the minus 6. So first of all, let's just look at what my sequence looks like. So I get 10. To get the second one, I times by a third. So I get 3.3 recurring. Times by a third again, I get 1.1 recurring. So it's constantly getting smaller. And it's saying how many terms are what will be the first term when it's less than 10 to the minus 6. So since I'm using inequalities, it's probably easier to think of this as equals. So by solving equals instead. So un is equal to 10 to the minus 6. Now I've got a formula for un. If I just write this up here because it's geometric, so I can use the formula a r n minus 1. I know a is 10, so it's 10 times a third to the power n minus 1 is 10 to the power minus 6. I can divide both sides by 10, so I get a third to the power n minus 1 is 10 to the minus 7 now, because I'm just taking away 1 from the power. Now, to get rid of the base third, I can use ln's and logs. So n minus 1 is log a third, 10 to the minus 7. And then to get n, I'll just add 1 to it. So 1 add log a third, 10 to the minus 7. So if you type that in your calculator, get 1 plus log third 10 to the minus 7. So I get n is 15.6713. So if n was that, that's when it would be exactly 10 to the minus 6. So n would equal 16. I need 16 terms before I get a term that's less than 10 to the minus 6. Now, if I dealt with inequalities, so imagine I left all this as inequalities, I would have, I'll just do it over, that'll be less than, less than, less than. But if you look here, if n was less than 15.671, n should be 15. So at some point, the inequality sign would have flipped. Now that's why I chose to use equal signs, because when I do logs, if the base is bigger than 1, the inequality stays the same. But if the base is less than 1, the inequality sign flips. So I get that, bigger than, so n is bigger than 15.671, so therefore n equals 16. Yes, but it's probably easier for you to think about this as equals, as an equation, instead of inequalities, because logs gets a bit trickier. Yeah, so for example, if I have a to the power x is less than y, then x is less than log y if a is bigger than 1. If a is less than 1 though, so it's between 0 and 1, then the inequality sign flips. And it's to do with it being a negative, that log now becomes negative. Okay, now if you think of series, if I have a geometric series with the first term a, common ratio r, then the sum of the first n terms is given by this formula here, and you're given this formula. I tend to just use the first one. However, using the second one helps if r is bigger than 1, so you don't have lots of negatives. But it doesn't particularly matter, you can use either one. To get from the first one to the second one, I've just times top and bottom by -1. So again, the proof for this one, well, if I write out all the terms I want, the first term is a, the second term would be ar, then ar squared, all the way up to the last term, which would be ar n minus 1. The nth term would be that, remember? And then the trick is, for the arithmetic one, I rewrote it, but backwards. This one's a bit different. I'm going to times that sequence by r. And I'm going to write it kind of to the left. So if I times a by r, I get ar, times ar by r, I get ar squared, etc. There'll be a term here, when I times by r, I get ar n minus 1. And when I times this one by r, I get ar n. If I call this sequence 1, sequence 2, if I take them away, actually I don't need to call them that, I can just write a takeaway here. Look. If I take them away, I've got Sn, take away Rsn, gives me, well, I get A, these two will cancel, these two will cancel, the middle will cancel, these two will cancel, and then I'll get 0 take away Ar to the power n. If I factorize out the Sn from the left hand side and factorize out the air from the right hand side, and then a simple division, just give me the formula I want. Job done. Okay, let's look at some problem solving questions. How many terms are needed for the sum of a geometric series 3, 6, 12, 24 to exceed 100,000? Well, from the question, we can see that the first term is 3, and the common ratio, well, to get from 3 to 6, 6 to 12, times by 2. And I want the sum to exceed, to be bigger than 100,000. So again, I'm going to use an equal sign here. Well, I've got a formula for Sn because it's geometric. So Sn formula is A times 1 minus Rn over 1 minus R. So if I write that out, so A was 3, so 3 lots of 1 minus 2 to the n divided by 1 minus 2 gives me 100,000. I'm going to times top and bottom by minus 1. So I get 3 lots of 2n minus 1 over 2 minus 1. It's 100,000. I simplify that to 3, 2n minus 1. At the bottom, 2 minus 1 is 1. I'm going to divide both sides by 3. Then I'm going to plus 1 to both sides. And then to get rid of the 2, the base 2, I'm going to do log 2. So n is log 2, 100 and 100,003 over 3. I'm going to work that out. And I get n is 15.0247. So when I have 15.0247, I get 100,000 for my sum. So therefore, I need n to be 16 to exceed it, because 15 won't be enough. So I'll need 16 in the next number of terms. Now, if I look back, what would happen if I had inequalities? So let's use green. So bigger than, that would stay the same. That would stay the same. I haven't done anything there. Dividing by 3 doesn't change it. Adding 1 doesn't change it. When I do logs, the base is 2, so it's bigger than 1, so it doesn't change it. So it stays the same. So n is bigger than 15.0247, so that's why n is 16. So it works with my inequality method as well. Okay, the last thing to look at with geometric sequences and series are infinite series, so series that go on forever. So as n increases, so the number of terms my sequence increases, my sum to n, my sum of all the terms, will either converge or diverge. So it'll either go towards the limit or it'll go towards infinity. Now, if the modulus of r is less than 1, so in other words, if r is between minus 1 and 1, then my sum to infinity, my Sn, will converge towards the limit, and I write that limit as S infinity. That just means the number it converges to. However, if the modulus of r is bigger than 1, so that means r is bigger than 1, or r is less than minus 1, then they'll diverge. And it's not hard to see why. So if I have, for example, the sequence where r is bigger than 1, so let's pick something like 1.5, my sequence would be 4, 6, 9, etc. That keeps getting bigger, so it's going to diverge when I add them together. Whereas if r is less than 1, so let's just do half, you get 4 times half, which is 2, times half, which is 1, times half, which is 0.5, so it's getting smaller and smaller and smaller. So that suggests that it might converge. And the formula, again, you're given this, if it does converge, it converges to A over 1 minus R. Now, the reason for that, if you think back to the formula for Sn, if r is between minus 1 and 1, that means r is quite small. When I do a small number to a big power, it disappears to 0, it gets very close to 0. So this Rn essentially disappears. So I just get A times 1 over 1 minus R. So I get that formula here. Okay, decide whether the following geometric series will converge And when they do, find the limit. So this first one, well, a is a half, and to get from a half to a quarter, and times them by a half. So that's smaller than 1, so it does converge. And in sum to infinity, the limit will be a over 1 minus r, which is 1. So half at a quarter and a at 1 over 16 is 1, and it's a nice visual padding, which again I'll show you in the lesson to show why that's true. Let's look at the next one. A half, take away a quarter, plus 1 over red, take away 1 over 16. So a is still a half, but this time r is minus a half. And then if I use the formula, half minus 1 minus minus a half, and if I work that out, I get a third. And again, there's a nice diagram which I can show you that shows that that's true. Next one, a would be a half, r would be 3 in this case. Now 3 is bigger than 1, so it diverges. So there's no limit, it goes off to infinity. When I keep adding the numbers together, it keeps getting bigger and bigger and bigger. And the last one, a would be 0.3, and r would be, well, what do I times 0.3 by to get 0.03? A would be 0.1, and that's less than 1, it's between minus 1 and 1, so it does converge. So the limit, s infinity, would be a over 1 minus r, and when I work that out, I get a third. Now, if you look at what that sequence actually is, that's just 0.3 recurring. So we're just proving that 0.3 recurring is the same as a third. That's another way of doing it compared to how we did it at GCSE. Just a little thinking point now. There's a distinction between a convergent sequence and a convergent series. So does one imply the other? So if my series converges, so this series here, let's do this one. So this series converged. Yeah, that converged to a third. So if I just look at the sequence now of just the numbers, is this sequence going to converge? And yeah, those numbers, if I keep timesing by 0.1, I'm going to get closer and closer to 0, so then will be 0. So if the series converges, that implies that the sequence converges. What about the other way around? Well, if I think of this sequence, a half, then a third, then a quarter, then 1 over 5, that's getting closer and closer to 0, so that's converging to 0. But if I add them together, what do you think about that series? Do you think that converges or not? Okay, and this in fact doesn't converge. This diverges. So it's one of these one-way implications. So if the series converges, that implies the sequence converges. But if the sequence converges, it doesn't mean the series will converge. Yeah, you don't need to necessarily know that, need to that for your exam. It's just interesting to think about, especially if you plan on doing maths after A level. Okay, let's look at an example now. So the sum to infinity of a geometric series is 5, and the second term is minus 6 over 5. Find the common ratio. So one's just to find r. Okay, well, it's a geometric sequence, so I can use the formulas. S infinity is a over 1 minus r, and the second term, so I need the un formula, which is a r n minus 1. I don't need the Sn formula, but let's just write it down just so you get used to seeing it. Okay, so the sum to infinity is 5, so S infinity is 5, and the second term is minus 6 over 5, So U2 is minus 6 over 5. Okay, now I can put the formulas in. So A over 1 minus R is 5. And A times R to the power 2 minus 1, so just R is minus 6 over 5. I'm trying to find what the common ratio is. So I want to eliminate A. Well, using the first formula, I can get A equals 5 times 1 minus R. Then if I sub that to the second one, I get 5 times 1 minus R times R is minus 6 over 5. So if I expand that out, I get 5R minus 5R squared is minus 6 over 5. And if I take it all to one side, I get 5R squared minus 5R minus 6 over 5 is 0. So I can use my calculator to solve that quadratic, or you could try and factorize it. But to save time, stick in your calculator. And I get R is 6 over 5, or R is minus 1 over 5. But the question, it says find the common ratio, so that means only one answer. Now remember, if the sum to infinity exists, R has to be between minus 1 and 1, but 6 over 5 is bigger than 1, so that doesn't work. So therefore my R has to be minus 1 over 5. Okay, let's look at another one. The geometric series 2 minus x plus 2 minus x squared plus 2 minus x cubed converges. So I know it's geometric, and I know it converges. Find the range of possible values of x. So that means range suggests an inequality. Well, let's write down first of all the first term is 2 minus x, and a common ratio is 2 minus x as well. Now, since it converges, I know that the ratio has to be between minus 1 and 1. So I know that R is between minus 1 and 1. So I've got 2 minus x is between minus 1 and 1. So I'm just going to solve that. I'm going to take away 2 from all sides. So minus 3 is less than minus x is less than minus 1. Now I'm just going to times everything by minus 1. And that flips the inequality sign. And I just like writing inequalities from small to big. So 1 is less than x is less than 3. So x is between 1 and 3. Yes, I didn't have to use any formulas at that time. I just had to use the fact it converges, which means R is between minus 1 and 1. Okay, write down the first 3 terms of this series. So, well, if I sub in R as 1, I get 4 times 5 over 6, which gives me 10 over 3, plus if I sub in R as 2, I get 25 over 9, and if I sub in R is 3, I get 125 over 54. Yes, that's the first 3 terms. Part B saying find the sum from R is 11 to infinity. So again, there's 2 ways I could do it. I can use one method where I can do, instead of starting at 11, I can start off with 1. So I can go from 1 to infinity, take away the numbers I included, so that's 1 to 10, so S10, and I can use the formulas where if I look at that, A would be the first term. If I subbed in R was 1, we got 10 over 3, so I get 10 over 3 over 1, take away R, which was 5 over 6, take away A, which was 10 over 3 times 1 minus r to the power 10 divided by 1 minus r. So I could use that. However, there might be a quicker way. So this way, on the other, when we did one for arithmetic, is just make a new sequence. So I sub in r is 11. I get 4 times 5 over 6 to the power of 11. The next term will be 4 times 5 over 6 to the power of 12. It goes on to infinity. So if I make this new sequence for this one, the first term will be 4 times 5 over 6 to the power of 11. That first number there. And r would still be 5 over 6, just like in the arithmetic one. The d didn't change here, the r is not changing. So the s infinity would be 4 times 5 over 6 to the power of 11 divided by 1 minus r, so 1 minus 5 over 6, which would give us, I don't think we'll get an exact answer this time, but let's try it. .23011 goes on forever. So 3 significant figures would be 3.23. Okay, if I do the other method, so this one, a would be the first term, so a would be 10 over 3 this time, so that's why I used 10 over 3. Let's see what we would get. 10 over 3 divided by 6. So the first term would be 20. Take away 10 over 3 times 1 minus 5 over 6 to the power 10 divided by 1 over 6. So that gives me 16.76988. And if I take them away, I get the same answer, 3.23. Yeah, so whichever way makes more sense to you. So either keeping the same sequence done with 1, so using the s's, or making a new sequence, so therefore a changes this time. I'll ask you in class which way you prefer. So for the arithmetic one, I preferred doing the s method, so s whatever, take away s whatever. However, for the geometric one, I think it's a bit simpler just to make a new sequence. Okay, here's going to be a mixture where we put arithmetic and geometric together. So show that the sum from 1 to 16 of 2 to the power r plus 3 to the power, that should say r as well, not d. So you have to do all the typos. Next year's year 12s won't get any typos. Plus 5 equals 131,558. So this one, split the sum into 3 different sums. So first one, 1 to 16, 2 to the power r, that's geometric. A would be, if I sub in 1, a would be 2, and the ratio, well, what do I times 2 by to get the second term, which would be 4, is 2 as well. So a is 2, r is 2, n is 16. So if I use the sum to Sn formula, so I'll get a times 1 minus r to the power n divided by 1 minus r. So I'll work that out. 2 times 1 minus 2 to the power 16 divided by minus 2. I get 131070. If I look at the second one, r is 1 to 16, 3r. Well, that formula looks like a geometric one. Sorry, an arithmetic one. So here a would be 3. The first one would be 3, and the common difference would be 3, and there's 16 terms. So S16, well, this formula, was n over 2 times 2 times a plus n minus 1 times d. And if I work that out, I get 403. And the last one, sum from r's 1 to 16 of 5. Well, notice how that doesn't have any r's in, so that just means I'm adding 5 together 16 times. So that's just 16 lots of 5, which is 80. So my original sum is these three numbers added together. Oh, sorry, that should say 408, not 403. I can't read the calculator properly. Which gives me 131,558, which is what the question wanted. Yeah, so split it up into a geometric, arithmetic, and just a number one. Here, a sequence is defined by, this time we've got a term-to-term rule. So the next term is 2 over the current one, and it starts with u1 is 3. Well, for this one, there's no formulas for when they're written like this. They're only formulas when they're position determined rules. So let's write out the first few terms, see what happens. So the first term, u1 is 3. u2 would be 2 over u1, so that's 2/3. u3 would be 2 over u2, so 2 over 2/3 gives me 3. So you can see it's going to keep alternating, so it's a periodic sequence. So it goes between 3 and 2/3, u1 and u2, and I want all the terms up to 100. So u100 is going to be in this column. Well, one row is going to add together. If I add these, I'm going to get 11 over 3. And there'll be how many rows? How many 2's going to 100? There'll be 50 rows. So it's going to be 50 lots of 11 over 3, which is 550 over 3. Yeah, so when you have a term-to-term rule, it's good to write out the first few terms to spot what the pattern is. Okay, and last page, this is when we can use sequences for modeling scenarios. So Bruce starts a new company. In year 1, his profits will be £20,000. He predicts his profits to increase by £5,000 each year. So that his profits in year 2 we modelled as 25,000, year 3 will be 30,000, and so on. He predicts this will continue until he reaches annual profit of 100,000. He then models his annual profit to remain at £100,000. Calculate the profit for Bruce's model, Bruce's business in the first 20 years. Okay, well, let's think. If the first year, so U1 is 20,000, U2 would be 25,000, U3 would be 30, etc. And it's going to keep increasing until it gets to a certain year, which I'll call K, where it's 100,000. It's then going to stay the same until we get to U20, which will be 100,000 as well. So let's think what type of sequence it is. Well, up until this point, it's an arithmetic sequence. Yeah, the first term is 20,000, and the common difference is 5. So the formula to begin with is 20,000 plus n minus 1 times, sorry, it's 5,000, isn't it, d? trying to ruin his profit. And if I expand and simplify that, I get 5,000 N plus £15,000. That's my nth term formula. So let's see how many years it takes them to get to 100,000. So I call it K. So UK was 100,000. So 5,000 K plus 15,000 is equal to 100,000. So take away 15,000 from both sides to get 85,000 and divide both sides by 5,000, which gives us 17. So it takes us 17 years. It takes Bruce 17 years to get to 100,000. So if I change this to 17 now, so that means for U18 it'll be 100,000, U19 will be 100,000, and U20 will be 100,000. So to work out the sum of all the profits in the first 20 years, I need to do S17, so the sum of the first 17 years, and I need to plus the final 3 years, which is 3 lots of 100,000. Well, S17, so N will be 17, so it's 17 over 2 times 2 times A, so 2 times 20,000, plus N minus 1, so 17 minus 1 times D, which is 5,000. That gives me how much he earns for 17 years, plus 300,000. So if I work that out, we get £1,320,000. So in the first 20 years, that's how much he earns. Well, that's how much his profits are. If you do business, that doesn't mean how much he earns. Okay, B. State one reason why this may not be a suitable model. Well, here the profits are rising at a constant rate. So here, profits may not increase uniformly. If it's a new business, it might get more profits slowly, then it might gradually get bigger. Okay, see, Bruce's financial advisor says the yearly profits are likely to increase by 5% per annum. So that means my multiplier, if I'm thinking of multipliers, will be 1.05. Using this model, calculate the profit for Bruce's model in the first 20 years. So let's use different code for this one. So let's see, if it's 5%, so the first year will be 20,000. Second year, well, I'll do 5% of that. So times it by 1.05, I'll get 21,000. And then the next term will be 22,050, etc. So this is a geometric sequence now, where the first term is 20,000 and the common ratio is 1.05. So if I do the sum to 20, using the formula, it's A times 1 minus R to the power N divided by 1 minus R. So if I work that out, we get 661,319.0821. So 661,319.08. So its profits in the first 20 years would be £661,319.08, to be precise. Now, we can use all the stuff we've done with sequences and series to model real life stuff. Again, it's just like doing what I've done, where you just pick out the keywords, pick out the key numbers, and write them as a sequence. Get rid of all the faff and write it as a sequence. So try to practice until you become really confident with these.